Scientific discoveries don't always start with, a eureka, I have found it kind of a moment. They often start with just a hunch, just a kind of suspicion, an uneasy feeling.
That's how Charles Moore described a pivotal moment that changed his life. His extraordinary story will be the starting point of this documentary, and the insight that struck him will serve as a wake-up call for all of us, for all of humanity. So let's start from the beginning.
The era of great geographical discoveries is long gone. Today, no one imagines there are still dark spots of unexplored continents, archipelagos or islands on the globe. Reading adventure novels about pirates and conquistadors, we envision the vast blue expanses of oceans and seas. Exotic islands lush with greenery and a plethora of magnificent birds, fish, and animals. This was the mindset of Charles Moore, a playboy and yachtsman, the son of a wealthy chemical company owner. Charles grew up by the Pacific Ocean, dreaming of maritime adventures since childhood. In 1997, he participated in the Trans-Pac yacht race, held between Los Angeles and Honolulu. On his return trip from Hawaii, he plotted his route through an area known as the North Pacific Gyre. After several days at sea, Charles realized his yacht was surrounded by trash. He and his friends had sailed into a floating garbage dump.
That passing over 1,000 miles of deep ocean in the middle of nowhere, I couldn't come on deck without seeing a piece of plastic pass by in a few minutes.
After this voyage, dreams of romantic adventures across vast blue waters, exotic lands and islands teeming with unique animals and plants were shattered. The ocean's surface no longer inspired awe with its pristine and untouched beauty. Sailing through tons of plastic waste deeply shocked and changed Charles Moore's life. What he was about to discover defied his understanding. Captain Moore became a pioneer, but his discovery brought no joy, because he discovered what would later be called the Great Pacific Garbage Patch. Charles transformed from a carefree playboy into a serious man and zealous advocate for environmental protection. Having sold his shares in his father's chemical company, he used the proceeds to establish the environmental organization Algalita Marine Research Foundation, AMRF, dedicated to studying the Pacific Ocean's ecological state.
Charles Moore's journey was far from easy. For a long time, his reports and warnings were dismissed, and his research was not taken seriously. And there were reasons for that. The oceanographer was urging governments worldwide to reduce plastic production and consumption while allocating substantial funds for its recycling. His request wasn't just for a little, but a significant amount of money. Yet, Charles achieved something crucial. He shook the global environmental community and drew attention to the plastic pollution in the world's oceans. But at the same time, no one fully grasped the danger of what had happened to the oceans and its impact on the life on our planet as deeply as he did. And Charles took the first step. That is, he uncovered a problem. But how does this discovery affect each of us? And what is next? How can we prevent the catastrophe from escalating? To answer these questions, we must first understand how global ocean system works and how it was damaged so severely.
Functions of the ocean. The ocean is a vast world that captivates our imagination and scientific curiosity. Its ecosystems, like intricate clockwork mechanisms, maintain the delicate balance necessary to sustain life on Earth. The ocean functions as the planet's natural air conditioner. It absorbs heat and gradually releases it. Remarkably, just a 10-meter layer of ocean water can store more heat than the entire atmosphere. The ocean's heat capacity is a unique ability that moderates temperature fluctuations between day and night, as well as between seasons, such as summer and winter. Ocean currents circulate around the planet, transferring heat and nutrients from equatorial regions to the poles and vice versa. This process mitigates temperature extremes. Ocean temperatures influence the life cycles of animals and plants, both in the ocean and on land. The ocean actively affects atmospheric processes, contributing to cloud formation and precipitation. Every day, vast amounts of water evaporate from its surface, condense into clouds, and return to land as rain or snow. This process is crucial for replenishing rivers, lakes, and soil with fresh water. Microscopic algae, such as phytoplankton, produce about 50% of the oxygen humanity breathes. Every second breath we take is a gift from the ocean. The ocean is also home to millions of species of living organisms, from tiny microbes to majestic whales. It harbors species that have existed for hundreds of millions of years. The ocean is where life began, and the future of our planet depends on it.
The ocean is a single interconnected organism that encompasses all of our planet's water resources. But as it turns out, this incredibly complex living system is very ill. And the reason for this is our careless handling of the plastic after its use. Plastic is a remarkably durable and convenient material, yet plastic pollution is a poison to the ocean. Charles Moore was the first to recognize that the true scale of this catastrophe. Each day, our ocean is becoming more polluted, and we're inching closer to the point where this illness will become incurable. As with any patient, the first step toward recovery is studying the medical history and making a proper diagnosis.
2 years after his shocking discovery, Charles launched a second expedition to thoroughly investigate the so-called garbage patch. And the findings from this expedition astonished the scientific community.
But in 1999, that was truly the discovery, because in 1999, after we analyzed our samples, we realized that there was 6 times as much plastic in the surface waters by weight as zooplankton, the basic food of the ecosystem. So the fact that plastic outweighed the life in the ocean was alarming to so many different people.
The Great Pacific Garbage Patch is, in fact, the largest dump on the planet, growing rapidly since the 1950s. This oceanic dump stretches from the west coast of North America to Japan. Its area varies, but is estimated to be around 1.6 million square kilometers or 580,000 square miles. The garbage patch contains at least 80,000 tons of waste. And this is just the tip of the iceberg. Approximately 70% of plastic sinks to the ocean floor, where a significant amount of marine debris likely resides. No one knows the true amount of trash within the Great Pacific Garbage Patch. The North Pacific subtropical gyre is too vast for scientists to study comprehensively. Measurements show that the garbage patch is growing at an alarming rate. From 2015 to 2022, the average mass of plastic within it increased 5-fold, while the number of smaller plastic fragments grew 10-fold. Marcus Erickson, research director at the Algalita Marine Research Foundation, USA, noted, "The original idea that people had was that it was an island of plastic garbage that you could almost walk on. It is not quite like that. It is almost like a plastic soup." The Great Garbage Patch is becoming the planet's 7th continent. But it is not the only one. Today, scientists have identified 5 major garbage gyres, 2 in the Atlantic Ocean, 2 in the Pacific Ocean, and 1 in the Indian Ocean. Millions of tons of plastic and other debris float in the oceans. According to research, up to 80% of the trash in these patches consists of plastic waste. Garbage islands are growing at a catastrophic rate. If we look around, we'll notice the following. 8 out of 10 items around us are made of plastic. We sleep on pillows with plastic filling, brush our teeth with plastic toothbrushes, and drink from plastic bottles. You are watching this film on a screen made of plastic, whether it's a TV, laptop, or phone. It's simply impossible to imagine our modern life without this material. The world around us has become plastic. Plastic is one of humanity's most pressing problems today.
We decided that because there was no focus on plastic pollution, we would take the lead in beginning to create what came to be known as the Great Plastics Awakening, the awakening to the idea that this material that is probably the most common material in our daily lives. I like to say that next to sleep, the most time that we waste is opening things wrapped in plastic, because we take so much time just taking things out of the plastic that covers everything.
What are the disastrous consequences of uncontrolled dumping of plastic waste into the world's oceans?
And the basic problem is that plastic, unlike other substances, doesn't go away. It remains in the environment. It doesn't go through the normal biodegradation cycle. It was invented to defeat natural decay. So in defeating natural decay, it made itself a permanent part of our environment.
So now we have a basic understanding of the Great Garbage Patch. Its size is truly enormous, and it continues to expand. But what is happening at the heart of this disease? Maybe plastics simply float in one place and eventually sinks into the ocean depths where they decompose under immense pressure. Maybe this is as alarming as it seems. So what have we learned so far?
Decomposition of plastic into micro and nanoparticles.
It is now one of the leading causes of death of marine creatures and needs to be investigated on that basis as a killer. It's a predator that kills but never eats. And it's also something that's predated upon, that fills up stomachs without giving nutrition. So it has a black, dark, evil side that is both killing and being consumed and killing. It strangles and it fills up bellies, and it's doing that at a greater and greater level. And that's just at the microplastic level.
Every year, more than 400 million tons of plastic waste are produced globally, and by 2040, this figure is expected to triple. Around 11 million tons of plastic enter the world's oceans annually, the equivalent of over one garbage truck of plastic dumped into the ocean every minute. Currently, our oceans already contain approximately 200 million tons of plastic. Studies suggest that by 2050, the amount of plastic in the ocean will likely exceed the total weight of all fish. Plastic takes 500 to 1,000 years to decompose. The Environmental Protection Agency states that basically 100% of all plastics human beings have ever created are still in existence. This waste does not disappear, it only accumulates. Imagine a dumpster in your backyard where trash is constantly added, but no one ever removes it. What would that dumpster look like after a month? Plastic waste floating in the water column becomes trapped in ocean currents, carried to central regions of the ocean, and forms massive garbage patches. These areas contain items such as fishing nets, disposable bottles, packaging, toilet seats, dolls, traffic cones, soccer balls, rubber ducks, and even TVs. Plastic doesn't biodegrade. However, under the influence of wave action, salt water, and sunlight, it breaks down into small fragments, sometimes invisible to the naked eye. These tiny particles, known as microplastics and nanoplastics, retain their polymer structure. The breakdown process continues down to the molecular level. The amount of microplastic, how much of it is there? Microplastic particles resemble a fancy mosaic. They are formed from various types of plastics and chemical additives, which change depending on their stage of degradation and environmental exposure. As a result, microplastic in the environment cannot be viewed as something fixed or constant. Studying it is a true puzzle for researchers. Although the exact amount of microplastic in the oceans remains unknown due to technical challenges in detection, Theoretical calculations help illustrate the scale of this threat. Given that currently an estimated 200 million metric tons of plastic waste are present in the oceans, we can do a thought experiment. If we imagine breaking all the plastic in the oceans into 50 nanometer particles, considering their density and the volume of the world's oceans, the resulting number is horrifying. Each liter of ocean water would contain 286 million of such particles. While not all plastic in the oceans has yet degraded into micro and nanoplastics, we understand that sooner or later, it will inevitably fragment into countless nanoparticles. Already today, scientists detect microplastic particles in every drop of ocean water. Moreover, there are regions within the ocean where the concentrations of microplastics are significantly higher. Most global scientific studies describing the scale and volume of marine plastic pollution have been limited to the ocean's surface layer. Research shows that approximately 358 trillion microplastic particles are floating on the surface of the world's oceans. However, growing evidence indicates that countless trillions of microplastic particles are also present in deeper waters and seabed sediments. Lightweight plastics tend to remain afloat, while denser plastics, or those colonized by marine organisms, sink to the ocean floor. According to estimates, about 50% of plastic waste from urban sources has a higher density than seawater, causing it to settle on the seabed, be carried by deep-sea currents, and accumulate in trenches and depressions. Microplastics have even been detected at the deepest point of the ocean, the bottom of the Mariana Trench. In reality, it is not the ocean's surface but the deep-sea floor that serves as the primary repository for microplastic debris. Consequently, the entire seabed is gradually being covered with a plastic layer. However, data on ocean pollution by microplastics are underestimated, and the reality is far worse. Not everyone has access to very sophisticated and expensive instruments and sampling tools, explains Melanie Bergman, a biologist at the Alfred Wegener Institute in Germany. In her opinion, as much as 90% of marine microplastic particles may be missed by standard sampling techniques because they're too small to be detected. The highest concentration of plastic is in garbage patch zones. These oceanic dumps act like factories for the continuous production of microplastics. Similar to how a virus spreads through the bloodstream, microplastics are dispersed throughout the global ocean system by currents. Since oceanic gyres are present in all the world's oceans, microplastics accumulation is occurring on a global scale. Even a remote and uninhabited region like the Arctic is no exception. Ice core studies have shown that microplastic pollution levels in the Arctic Ocean are 2 orders of magnitude, 100 times, greater than those in the Pacific Gyre. In addition to the 2 layers of pollution, the surface and the bottom layers, the concentration of microplastics significantly increases in another area, the thermocline. This is the layer of water where temperature changes sharply with depth. Due to high-density gradients in this layer, micro and nanoplastics become trapped, remaining suspended there for extended periods. Picture the ocean as a layered cake, where each layer has distinct temperature and density characteristics. Microplastics tend to accumulate at the boundaries between these layers. Additionally, microplastics can also be transported in the ocean by marine organisms that ingest, digest, and excrete plastic particles.
It's now undeniable that microplastics are everywhere. They're present in all bodies of water, as ocean, rivers, and lakes on our planet are all interconnected. But some may argue, well, okay, fine, but microplastics are so small that they're not something that I should worry about, right? I mean, I don't see them in the water that I drink or in the tomatoes in my salad, even though they were grown with water, which is all part of the interconnected global water cycle. So maybe they're not as dangerous as they seem. But are they?
Microplastics, a source of toxins and bacteria. Influenced by sunlight and waves, plastic breaks down into small particles. releasing dyes, plasticizers, and other chemical compounds into the ocean water. Many of these substances are toxic. As a result, ocean water turns into a toxic soup. In this soup, plastic continually breaks down into micro and nanoplastics, making the ocean increasingly toxic. Studies have shown that nanoplastics are more toxic than microplastics due to their greater ability to act like a sponge, absorbing pollutants from water and air. The surface of plastic waste becomes home to harmful algae, colonies of bacteria and fungi, which rapidly multiply. These plastic islands are a source of pathogenic microorganisms capable of causing dangerous diseases in humans and animals. Moreover, plastic debris can serve as a bridge that allows coastal organisms to reach the open ocean, disrupting the fragile balance of ecosystems. As a result, these garbage islands become breeding grounds for dangerous bacteria, posing a threat to all living beings. Microplastics kill living organisms. Plastics have a significant impact on marine ecosystems. Every year, more than 1 million seabirds and 100,000 marine animals die due to plastic pollution. 100% of baby sea turtles have plastic in their stomachs. If a coral comes into contact with plastic, its likelihood of developing a disease increases from 4% to 89%. This is disastrous, as coral reefs are home for a quarter of all marine life.
Great extinction that we're undergoing, similar to the extinction that wiped out the dinosaurs, will wipe out life again on the planet. And there's some truth to that. Life is being wiped out. I believe it's being wiped out in the ocean by plastic principally right now. It's being wiped out on land by climate change and by plastic.
Microplastics are so tiny that plankton ingest them. Plankton is the foundation of the food chain. Many marine species feed on plankton, and those that don't consume plankton eat creatures that have already consumed it. Thus, microplastics become part of the food chain. The larger the fish, the more microplastics it contains. According to research, the largest animal to ever live on Earth is also the biggest consumer of microplastics. Each whale consumes up to 43.6 kilograms, 96 pounds of plastic per day. However, whales don't take in plastic directly from the water. 99% of the microplastics enter their bodies through their food. In other words, plastic is already present in the prey whales consume. It's worth noting that smaller microplastics have a more dangerous impact on organisms at the cellular level. Nano-sized plastic particles penetrate cell membranes and remain inside the cells, as they are not expelled from the body. Moreover, micro and nanoplastics damage DNA inside the nucleus. Plastic particles not only contain toxic substances, but also absorb organic pollutants from seawater and host colonies of bacteria. Ultimately, all of this ends up in the human body through seafood consumption. So we're not just eating our own trash. We're eating trash seasoned with toxins, bacteria, and fungi. Moreover, micro and nanoplastics enter our bodies through other food products, drinking water, air, and even sea breezes.
Now we know that these microplastics become nanoplastics. They become airborne, they get into our water, and they get into our food and even our vegetables. So not only was our initial findings that, it was a big problem for marine creatures, now it's a problem for everything. Everybody, every habitat, you name it. Well, now we know that you are getting sick from plastic. Your life will be made shorter by plastic.
Micro and nanoplastics accumulate in the bloodstream and are transported to various human organs. Microscopic plastic particles have been found in blood, brain, heart, lungs, breast milk, placenta, and, most recently, in penises, testicles, and human semen samples. The toxic substances released from plastic disrupt the endocrine system, leading to severe consequences, including infertility, hormonal imbalances, and an increased risk of cancers, such as breast, ovarian, and prostate cancer. Chemical additives in plastics also negatively impact the cardiovascular system and increase the risk of atherosclerosis. Once they reach the brain, micro and nanoplastic particles raise the likelihood of neurodegenerative disorders such as Alzheimer's and Parkinson's disease. Inhalation of plastic particles contributes to the development of asthma and even lung cancer. Hydrogen bonds are the key binding force that organizes matter into highly structured forms. Studies reveal that in the presence of nanoplastics, protein molecules deform due to the formation of strong hydrogen bonds between the nanoplastics and the proteins. Remember that all living organisms are composed of proteins, therefore their deformation can have serious biological consequences, affecting the functioning of cells, tissues, and organs. This puts the existence of all life on the planet at risk.
So as we can see, the issue of garbage patch, where plastics break down into microparticles and spread through all water bodies of our planet, this turns out to be much broader in scope. One key takeaway is that the problem of micro and nanoplastics affects every human being and all life on this planet. Now, we would like to point out that nanoplastics are even more dangerous than viruses because while viruses invade cells, nanoplastics go even further. That is, they affect protein molecules. And since all living things are composed of proteins, nanoplastics, they pose a direct threat to all living organisms. In fact, they can even affect the very carrier of the genetic information, the DNA, potentially causing the strain breaks and genetic mutations. So issues related to plastic should concern all of us. But that's only the part of the story. Because interestingly, just as the amount of plastic waste in the ocean is rapidly increasing, so is the frequency and severity of natural disasters. So that makes one wonder, is there a connection between a micro and nanoplastics which has infiltrated every drop of water and the changes we're witnessing in the climate? Or perhaps there is no connection and the weather will soon return back to normal, right? Before we answer these questions, let us take a closer look at what is happening with the climate.
Ocean warming. UNESCO's State of the Ocean Report 2024 reveals alarming new data. The rate of ocean warming has doubled over the past 20 years, and ocean heat content has reached an all-time high. Research indicates that between 1955 and 1986, the world's oceans warmed at a steady rate. However, in recent decades, the rate of warming has accelerated significantly. In 2023, global ocean surface temperatures hit an all-time high in recorded history, and 2024 has continued this upward trend. The sea surface temperature remained at record high levels for 15 consecutive months. For the first time in history, the average global temperature rose by 1.5 degrees Celsius above pre-industrial levels. According to experts, this very indicator is the critical threshold that will lead to massive climate upheavals. This increase was expected by the mid-21st century, but in reality, we have already crossed it. According to UN projections, this trend is expected to continue, with global temperatures potentially rising by nearly 3 degrees Celsius by the end of this century. Jeff Smith, Emeritus Professor in Applied Physics at the University of Technology, Sydney, UTS, said accumulated data over 70 years showed an accelerating rise in ocean temperatures and the total energy stored in oceans. Current scientific models in the presence of ongoing rises in atmospheric greenhouse gases do not predict this threatening acceleration, Professor Smith said. Furthermore, over the past 60 years, the oceans at greater depths have warmed 15 times faster than during the previous 10,000 years. This indicates that global warming processes are not limited to the ocean's surface, but also affect deeper parts of the ocean, where sunlight cannot penetrate. To heat water at such depths requires a vast amount of energy, which reflects the scale of the problem. According to scientists, to achieve the current rate of ocean warming, The energy required would be equivalent to exploding 7 atomic bombs, the same bombs dropped on Hiroshima, every second, continuously, for an entire year. These are staggering figures that raise a crucial question: where is all this energy coming from? As ocean temperatures rise, sea levels continue to climb, threatening to submerge entire coastlines. Over the past 2 centuries, global sea levels have risen by 21 centimeters, 8.3 inches, with 10.1 centimeters, 4 inches, of that occurring in just the last 30 years. Sea levels are now rising 2.5 times faster than before, and this trend continues. If this trend persists, millions of people will become climate refugees, forced to leave their homes and seek shelter away from coastal areas. Additionally, since the 1960s, the ocean has lost 2% of its oxygen due to warming of its waters and pollution from industrial, domestic, and agricultural runoff. Coastal marine species are suffocating from the declining oxygen levels. Around 700 dead zones have been identified, areas where marine flora and fauna have nearly vanished. Ocean warming is also driving more frequent and severe extreme weather events, such as floods, typhoons, and abnormal precipitation. All of this poses a serious threat to the planet's ecosystems and the lives of billions of people. Each year, this process accelerates, and the changes become more and more evident. Anomalous increase in natural disasters. For years, the ocean acted as a natural regulator of the Earth's climate. However, it is now becoming a source of destructive phenomena. Abnormal precipitation and floods. The warming of ocean waters intensifies evaporation, saturating the atmosphere with moisture that eventually precipitates as heavy rainfall. Here is how the frequency of anomalous precipitation events in Europe has changed since 2000. Record-breaking precipitation levels have reached new extremes. A month's worth of rainfall occurring in a single day no longer surprises anyone. Entire annual rainfall totals pouring down over just a few days, or even hours. That's the new reality. In Iran, nearly 3 years' worth of rainfall fell within just 3 days. In Oman, the region experienced 2 years' worth of rainfall in a single day. Meanwhile, in the United Arab Emirates, an astonishing 5 years' worth of rainfall fell in just 24 hours. Avoiding catastrophic flooding under such extreme rainfall conditions is impossible. Unfortunately, a deadly flood in Spain serves as a striking example. In the Valencia region, more than a year's worth of rainfall fell within just 8 hours. The result was devastating floods that claimed the lives of over 220 people and turned urban streets into a chaotic landscape of mud, wrecked vehicles, and debris from collapsed buildings. Unprecedented, unrelenting floods struck southern Brazil starting in late April. The disaster claimed the lives of 181 people. More than 500,000 people were left homeless. Floodwaters claimed hundreds of lives in the northern provinces of Afghanistan. Torrents of mud and water devastated entire settlements. The flooding was triggered by unrelenting downpours that followed a prolonged drought. In Russia, the spring floods of 2024 turned into a national catastrophe, affecting 39 regions across the country. The most severe situation was in the Orenburg region. There had been no flood of such scale in the region's entire recorded history. Kazakhstan faced the most extensive floods in 80 years. 10 out of 17 regions of the country were affected. Around 100,000 people were evacuated. Flood statistics. In the 1970s, there were only 260 major floods over a period of 10 years. However, from 2014 to 2023, the number of floods increased to 1,700, which means they became 6.5 times more frequent. In Europe, over the last 5 years, extreme precipitation has occurred 44 times more often than in the 2000s. In 2024, the time between catastrophic events has shortened, and their intensity has increased to such an extent that people cannot recover from one disaster before finding themselves in the epicenter of another destructive event. The consequences for the economy and infrastructure stretch for months or even years. Snowfalls. Snowfalls are also breaking all historical records. Last winter, massive snowstorms swept across Europe, the the USA, Canada, Russia, Kazakhstan, China, Turkey, Japan, and many other regions. Over 90% of Mongolia's territory was covered in snow, with some areas experiencing depths of more than 1 meter. The catastrophic damage was inflicted on pastoral regions, where around 4 million livestock perished from hunger and exhaustion. Temperature anomalies. In 2024, nearly all countries experienced and continue to endure record-breaking heat waves. On March 15th in Prague, Czech Republic, where the average maximum temperature usually does not exceed 9 degrees Celsius, a new temperature record of plus 18.6 degrees Celsius was set for the first time in 249 years of observations. April also brought unprecedented temperature chaos to Europe. In just 10 days, 128 countries set new heat records. In most European countries, temperatures in April were hotter than usual for midsummer. At the same time, one of the sharpest temperature fluctuations in recorded history was observed. In Slovenia, the temperature dropped by more than 26 degrees Celsius in just one day. In India, April temperatures reached as high as 46 degrees Celsius, far above the normal 35 degrees Celsius. People cannot endure such heat stress. After police officers working outdoors began losing consciousness, helmets with air conditioning were added to their gear. In Mecca, Saudi Arabia, several consecutive days in June saw temperatures remain above 40 degrees Celsius. The extreme heat coincided with the Hajj pilgrimage, during which more than 2,700 pilgrims suffered heat stroke on June 16th alone. People collapsed on the streets from the unbearable heat. Tragically, at least 1,300 people lost their lives. Tornadoes and microbursts. The increase in temperature and atmospheric humidity creates conditions for the formation of more powerful storms, which often lead to tornadoes. In recent decades, the average annual number of tornadoes in Europe has increased 18 times, and they have become much more powerful. On September 28th, a destructive tornado passed through the Moscow region. A tornado of such strength in the fall in temperate latitudes is an absolutely anomalous phenomenon. In recent years, atmospheric microbursts have been occurring with frightening frequency. When the air hits the ground, the descending airflow creates horizontal wind gusts, which can reach 130 kilometers per hour. It's like pouring a huge bucket of water from the sky, with a radius of about 5 kilometers. They can be super localized, as happened in Brazil. Here, a sports field was destroyed, leaving almost nothing but debris and trash, as if an explosion had occurred. Nearby buildings remained untouched, and even fragile solar panels were unharmed. It is important to note that microbursts cannot be predicted, making them even more dangerous. Hurricanes and storms. Hurricanes are now making landfall in areas that were previously considered safe. Only 3 hurricanes on record have ever struck Mexico's coastline near the city of Acapulco. 2 of them occurred within less than a year. Hurricane Otis in October 2023 and Hurricane John in September 2024, which became a nightmare for Mexico's residents. After nearly dissipating and moving out to sea, it unexpectedly regained strength and struck the country with even greater force. Typhoon Yagi brought an extraordinary amount of rainfall to Vietnam, resulting in at least 300 fatalities and hundreds of injuries. Hurricane Helene became the strongest hurricane on record. The deadly storm claimed the lives of at least 230 people across 6 states. It caused an estimated $250 billion in economic losses to the U.S. Less than 2 weeks later, another powerful hurricane, Milton, struck Florida. It took Hurricane Milton just over 12 hours to intensify from Category 1 to the highest Category 5. The Philippines faced an unprecedented string of natural disasters. 6 typhoons struck the country in less than a month, with 4 hitting within just 10 days. These disasters claimed at least 171 lives, caused significant economic damage, and affected 9 million people. The intensity and frequency of storms are also increasing. Starting on September 12th, Central and Eastern Europe experienced the most powerful storm in decades, Storm Boris. It claimed 26 lives and caused billions of euros in damages to the EU economy.
Of course, we've covered a small fraction of what is happening with the climate. The list of these could go on and on. But even with what we have presented, it's clear that the climate situation, in essence, is an undeclared war against humanity. We're being struck blow after blow. And while one can negotiate and lay down arms in a traditional warfare, you can't negotiate with the climate. Yet, we can, and we must defeat it. We'll talk more about this later. But in the meantime, it is crucial that we understand why all this is happening.
Why is the ocean warming? Hypothesis. The main widely recognized factors influencing ocean warming are greenhouse gases, such as CO2. These gases trap heat in the atmosphere, causing the upper layers of water to heat up. However, other factors may also play a significant role. Let's examine 2 graphs. A graph showing the increase in plastic concentrations in the oceans over recent decades. This data indicates a significant increase in microplastics in the ocean since the 1950s, coinciding with accelerated industrial development and the mass production of plastic goods. A graph showing rising ocean temperatures over the same period. This graph shows a parallel increase in the average surface temperature of the oceans, also beginning in the mid-20th century. By comparing these 2 graphs, we can observe a certain correlation between the rise in plastic concentrations and the warming of the oceans. This suggests that plastic pollution may be one of the significant yet underestimated factors contributing to oceanic warming. Let's explore how plastic might affect the ocean's functions, specifically the water's thermal conductivity and heat capacity, and how these processes may contribute to its warming. To understand this, we need to delve deeper into the structure and properties of water. Unique properties of water. Water is one of the most unique and enigmatic substances on Earth. What lies behind the simple chemical formula, H2O? And why does it possess such unique structure and properties? First, water molecules are the smallest among similar triatomic molecules. It is remarkably harmonious and fits the proportions of the golden ratio. The water molecule has a symmetrical V shape, as 2 small hydrogen atoms are positioned to one side of a relatively large oxygen atom. This sets water apart from linear molecules where atoms align in a straight chain. Under normal conditions, triatomic molecules usually form gases, while water molecules form a liquid. Why? Water molecules are interconnected by hydrogen bonds, creating a robust and ordered structure akin to a team bonded by strong friendship ties. Additionally, water molecules have the unique ability to cluster together. In other words, water is a complex liquid composed of recurring clusters. As a result, water has anomalous freezing and boiling points compared to other triatomic substances. If water followed conventional rules, it would freeze at around -100 degrees Celsius and boil at approximately +10 degrees Celsius. Virtually all of water's properties defy the conventional laws of physics governing other substances. First unique property: Water has the highest specific heat capacity and heat of fusion among known substances. This means water is harder to freeze, while ice is harder to melt compared to other materials. Thanks to this property, our oceans act as a climate regulator for Earth. Ocean water cools more slowly than air and soil, allowing it to store heat during the day and release it gradually at night. During summer, the ocean absorbs excess heat, while in winter, it gradually releases it. This makes the ocean a giant thermostat, moderating temperature fluctuations. Second unique property. When water's temperature changes, its properties also change. Water reaches its minimum value of specific heat capacity at a temperature of 37 degrees Celsius. This fact is of great importance for living organisms, as 2/3 of their bodies are composed of water. The normal body temperature of humans and warm-blooded animals, ranging from 36 to 39 degrees Celsius, falls precisely within this range. At this temperature, complex biochemical reactions of metabolism occur most efficiently. It's as if nature itself ensured that living organisms could retain their heat without expending much energy, allowing them to continue evolving. The third unique property of water. For most substances, density decreases when they are heated, as molecules move apart, and increases when they are cooled, as molecules come closer together. However, water behaves somewhat differently. When water is cooled to 4 degrees Celsius, its density indeed increases, like most other substances. But when cooled further, from 4 degrees Celsius to 0 degrees Celsius, its density begins to decrease. Thus, water reaches its maximum density at a temperature of 4 degrees Celsius, not at 0 degrees Celsius. And here's where it gets fascinating. When water turns into ice, its density immediately decreases by more than 9%. In other words, ice takes up more volume than liquid water. This is an incredibly unusual property of water. Because ice becomes lighter than water, it floats. By remaining on the surface, it protects the water and all living organisms within it from freezing completely. If the density of water increased upon freezing, ice would sink. In that case, all the water in lakes, rivers, and oceans would freeze solid, turning into massive ice blocks. This would lead to the extinction of all life. The unique properties of water are due to the presence of hydrogen bonds between its molecules. These bonds play a key role in determining water's physical and chemical properties. Changes in water's physical properties can significantly affect the thermal balance of the oceans, including their ability to store and transfer heat.
We now have nearly all the information we need to understand what's happening with the climate. So we know that the ocean is heating up at an alarming rate. And we know that in addition to the garbage patch floating on the Earth's surface, huge amounts of plastic cover the ocean floor. Moreover, we also learned that practically every drop of the ocean is filled with micro and nanoplastic particles. And the water itself possesses a unique properties. Now, what remains is the final step: understanding how these plastic particles are changing the unique properties of water. Once we understand this, the cause of the ocean's abnormal warming will become clear, and we'll know exactly what needs to be done.
The impact of micro and nanoplastics on water properties. Plastic is a petroleum-based material. It doesn't biodegrade. Instead, it breaks down into micro and nanoplastic particles. Nanoplastic particles are so tiny that they are even smaller than viruses. When they enter the water, these particles disrupt its orderly structure, which is based on hydrogen bonds between molecules. These bonds define water's key properties, and any disruption to them alters the physical and chemical characteristics of water. Nanoparticles of certain types of plastic, such as polyethylene terephthalate, PET, and nylon, contain oxygen and nitrogen atoms. These atoms can form hydrogen bonds directly with water molecules. As a result, such particles integrate into water's ordered structure, altering its organization and disrupting its fundamental properties. Moreover, in aqueous solutions containing various substances, as well as under changes in pH and temperature, nanoplastic particles can become electrically charged. This occurs due to chemical changes on their surface, such as oxidation, or through the adsorption of ions, like sodium and chloride, in seawater. Charged nanoplastic particles surrounded by ions attract water molecules, forming a multi-layered coat of water molecules around them. In chemical terms, this process is known as hydration, and the coat is referred to as a hydration shell. Researchers from the Federal Polytechnic School of Lausanne sought to determine the size of this hydration shell around ions, that is, how many water molecules respond to an ion. They arrived at astonishing results. It turns out that a single ion can influence approximately 1 million surrounding water molecules. This effect is amplified if the particle has a large surface charge and a high concentration of adsorbed ions. Consequently, a single nanoplastic particle can alter the properties of millions of water molecules. Molecules bound within the hydration shell are less mobile, which reduces their contribution to the overall heat capacity of water. In other words, such water heats up faster under the same external conditions and cools down more quickly compared to pure water. Moreover, the disrupted hydrogen bond structure around nanoplastics lowers water's thermal conductivity. This implies that water near nanoplastics can be warmer due to a reduced ability to dissipate heat. In this way, nanoplastic actively interacts not only with ions and impurities present in the water, but also with water molecules themselves, altering the hydrogen bond network that defines water's key properties. As a result, both the heat capacity and thermal conductivity of water change. This leads to an overall increase in temperature and contributes to the heating of the entire ocean. It is important to note that even a small amount of nanoplastics can have a profound effect on water properties. This underscores the need for further research and an assessment of nanoplastic concentrations in various aquatic environments to fully understand its impact. Nanoplastic particles in the ocean are like a fly in the ointment. Micro and nanoplastic particles are distributed throughout the ocean by currents. Buoyant particles remain on the surface, while denser microplastics or those contaminated with biota sink to the ocean floor. Moreover, let's not forget about thermocline zones. In these water layers, differences in temperature and density allow microplastic to accumulate in significant quantities. To better understand, let's use a visual metaphor of a multi-story building. Imagine a 10-story building with thermal blockages on the 5th and 10th floors, disrupting normal heat dissipation. Instead of evenly distributing heat, it accumulates on these floors and cannot escape through the roof. A thermal camera would reveal that the temperature inside this building is significantly higher compared to a similar building without thermal blockages. Similarly, nanoplastic in the ocean disrupts natural heat exchange mechanisms. Thus, an increase in nanoplastic concentration in ocean waters interferes with natural heat transfer processes. Over time, this can lead to a rise in overall ocean temperatures, which in turn impacts the global climate. When water warms, it attempts to release excess heat. During this process, its molecules move faster, rising to the surface. Impact on the atmosphere. With excess energy, some water molecules break away from others, turning into vapor. Imagine a balloon slowly ascending into the sky. This balloon represents water vapor. As altitude increases, air temperature decreases. In such conditions, water vapor begins to condense, forming tiny droplets. However, for these droplets to form, they need a pillar. Microscopic particles known as condensation nuclei. These can include dust, sea salt, or soot. The more condensation nuclei present, the faster the process. In the atmosphere, water vapor and droplets interact with ambient electric fields and atmospheric static charge, acquiring an electrical charge.
charges are really important, and in cloud formation, charges are practically everything. So if you're surrounded by foul weather and thunderstorms, you know that some clouds have electrical charges. But it was found long ago, but not currently considered to be important or relevant, that all clouds are actually charged. So if you look at a cloud, which I'm looking at right now, the question is, how do they form? What's going on there? And what we found is that charges are critical.
Charged droplets attract each other like tiny magnets, accelerating the formation of larger droplets. These droplets merge to form clouds and precipitation, including hail. However, when micro and nanoplastic particles come into play, they can disrupt the delicate balance of these electrical and water processes in the atmosphere. The interaction between ice crystals and aerosol particles, including plastic, amplifies the atmosphere's electrostatic charge. Moreover, micro and nanoplastic particles serve as effective condensation nuclei for water vapor. These charged particles cause water molecules to cluster around them and condense into droplets, ice crystals, or hail more quickly. The larger the surface area of the nanoparticles, the bigger hailstones and rain clouds they can generate. We are already witnessing these phenomena becoming more frequent and destructive. The presence of micro and nanoplastic can also influence the density and physical properties of ocean evaporation, slowing its ascent. It's akin to tying a small stone to a balloon with a string. As a result, clouds form at lower altitudes, typically below 2 kilometers, about 1.2 miles. Low-lying clouds are less efficient at moving and distributing precipitation. This imbalance triggers droughts in some regions while causing excessive rainfall in others. Denser clouds, like a blanket, trap heat in the atmosphere, preventing it from dissipating into space. Rising temperatures lead to even greater water evaporation from oceans and seas. And the more moisture in the atmosphere, the warmer it becomes. This creates a vicious circle. It also should be noted that for every degree of warming, atmospheric moisture rises by about 7%, while lightning strikes increase by 12%.
This moisture is generally coming out of the oceans. And so that provides all of the extra rain when we do have a storm. But in the meantime, in places where it's not raining, things are drying out a little bit quicker, and so droughts and heat waves are more intense, and wildfires as well. Those two ingredients, the increased temperature and the increased water vapor, lead to increased instability of the atmosphere. And what that leads to is more convection, more storms, that some of which, the more severe ones, become thunderstorms. And there's a greater risk of strong thunderstorms as a result. And if the thunderstorms get together and cooperate as they do in a tropical storm, you can end up with stronger hurricanes as well. And so all of those things are adding together, and there's an increased risk of the kinds of storms that severe thunderstorms, that supercell storms especially, that produce the hail, and also can, in some places, in the right conditions, produce tornadoes.
Extreme ocean heating combined with excess electricity and heat in the atmosphere exacerbates the climate crisis. Unusual hailstorms, torrential rains, powerful storms, hurricanes, lightning, and sprites are intensifying with alarming force. These climatic phenomena are becoming increasingly destructive and hazardous. Interaction with the planet's magnetic field. Oceans cover approximately 70% of the Earth's surface. They are not just massive reservoirs of water, but also an incredibly complex electrical system that interacts with the planet's magnetic field. The magnetic field protects the Earth's surface from solar wind and dangerous cosmic radiation. It serves as a shield, and without it, the atmosphere would be destroyed. This magnetic field is generated deep within the Earth, where the liquid outer core continuously moves around the solid inner core, functioning like a colossal natural generator. The field is generated by the core and interacts with electrical phenomena in the oceans and atmosphere. The presence of salts allows seawater to conduct electricity much like the wires in our homes, enabling the ocean to carry electrical currents. However, pollution in the oceans and atmosphere in areas with high concentrations of plastic, especially nanoplastics, alters the chemical and electrical properties of the water. The more polluted the water becomes, the more the atmosphere is affected. As polluted water evaporates, it carries metals, microplastics, and other substances into the air. Imagine holding a powerful palm-sized magnet, but if you place a piece of iron nearby, the iron would absorb part of the magnetic field, reducing the magnet's overall strength. A similar dynamic occurs between the atmosphere and hydrosphere. This disruption could lead to localized anomalies in the magnetic field, which warrants further research, particularly during a time of global climate change.
Yes, we now know that the main impact of the ocean on the climate is through its warming, and this effect is exacerbated by the microplastics. We really need to take immediate, decisive actions to clean the oceans in order to preserve our planet and all life on it. Today, at the highest levels, there is a growing recognition that we're rapidly approaching the point of no return.
Water crisis. The October 2024 report by the Global Commission on the Economics of Water, GCEW, states that for the first time in human history, the global water cycle is increasingly out of balance. Climate change is having an increasingly severe impact on water resource availability. By the end of this decade, the demand for fresh water will exceed supply by 40%, as global water systems face unprecedented stress. Approximately 70% of the world's fresh water is used to irrigate crops. However, many irrigation systems are inefficient, leading to significant water loss. Rising temperatures, shifting rainfall patterns, and more frequent extreme weather events threaten global food security. Projections indicate that over half of the world's food supply may disappear within the next 25 years, while 3 billion people already live under water-scarce conditions. This is a deeply alarming situation that will soon affect the entire world. The ocean's importance in sustaining life on Earth is undeniable, and world leaders are emphasizing the urgent need for action. UNESCO's State of the Ocean Report 2024 has the ambition to inform policymakers and drive actions towards the ocean we need for the future we want. The President of the UN General Assembly, Mr. Denis Francis, aptly remarked that the ocean is humanity's strongest ally in combating climate change. Therefore, it is our joint responsibility to course correct and recommit to sustainably manage the ocean's precious resources so as to ensure their availability intergenerationally.
And what scientists know is that if we don't have the ocean, we don't have the plants on land. We don't have the oxygen. We don't have the ability to survive.
UN Secretary General Antonio Guterres also emphasized the need for immediate action, urging governments, businesses, investors, scientists, and communities to come together in defense of our ocean. Marina Ovtsinova, president of the Allatra International Public Movement, made a key statement at COP29 regarding the unprecedented rise in climate-related disasters. She noted,
"We are failing to grasp how little time we have left before we reach the point of no return."
Clearly, maintaining the health of our oceans is critical for the planet's future.
So as we can see, there is an understanding about the seriousness of the situation. Many important discussions are taking place to clean up the oceans. But what concrete steps are being taken right now to heal our planet, which is affected by a dangerous virus? So far, we can only say one thing. The patient is more dead than alive, and it's only a matter of time before he stops breathing. So what are the doctors doing?
A Sisyphean task. In an attempt to improve the situation, efforts are underway to remove large surface debris from the ocean. Various organizations and initiatives are working on projects to collect plastic and other waste floating on the surface. The most ambitious ocean cleanup project is led by the Ocean Cleanup Organization. The system consists of a floating barrier approximately 2.2 kilometers, 1.4 miles long, which is towed between two slow-moving vessels. This barrier suspends a screen extending 4 meters, 13 feet, below the surface of the water, where most floating plastic is encountered. The debris is guided into a huge sack, which, once full, is pulled onto one of the vessels, where the plastic is sorted and packed. Afterward, the bag is put back in the water, and the process starts again. At first glance, this sounds promising, but there are a few concerns. Along with the trash, live organisms inhabiting the ocean's surface, such as microscopic algae, fish larvae, and jellyfish, also get trapped. No one has yet measured how many living organisms get caught in the nets, but if they are destroyed in significant numbers, it could have a cascading negative effect on marine life by disrupting the food chain. Despite efforts to ensure the safety of marine animals, the problem remains unsolved. As of November 2024, participants in the Ocean Cleanup Project have removed approximately 20,000 tons of plastic from the oceans. This is a significant step forward, yet in the grand scheme of the problem, it is merely a drop in the ocean. There are around 200 million tons of trash floating in the oceans, and this number grows by an additional 11 million tons each year. Just to understand the scale, 20,000 tons account for only 0.01% of the total oceanic waste. When examining the issue of cleaning up the oceans, numerous questions arise. For instance, even if we manage to remove all the plastic from the ocean, what do we plan to do with it? Currently, not more than 9% of plastic is recycled. Does this mean we'll simply dump it back into landfills? Moreover, cleaning up the trash is incredibly expensive. The Great Pacific Garbage Patch is too far from the shores of any country, leaving no single nation willing to take responsibility or allocate funds for its cleanup. According to Charles Moore, cleaning up this patch would bankrupt any country attempting to do so. And there are 5 such garbage patches across the oceans. Removing trash from the ocean while thousands of tons are extracted annually, yet millions more are dumped in, truly feels like a Sisyphean task. Cleaning the ocean will only be possible when it becomes a mission for all of humanity, not just the initiative of individual activists. Large debris is only a small part of the issue. That's only the plastic at the surface. That's only a small fraction. 1% of what's actually in the ocean, says marine biologist Melanie Bergman from the Alfred Wegener Institute. When plastic breaks down into micro and nanoparticles, cleaning the ocean becomes nearly impossible. While technologies to remove microplastics from water already exist, they are still in the experimental stage, far from being deployed on a global scale. The main challenges are their limited efficiency and the difficulty of scaling these solutions. Even if we were to collect all the large debris, what would we do about microplastics? They are dispersed throughout the ocean's water column, with particularly high concentrations on the seafloor. Microplastics represent the most significant threat.
Indeed, that cleaning up the ocean seems like a never-ending task. That is, the amount of waste being dumped into the oceans is orders of magnitude greater than what is being removed. So, what should we do? Clearly, the technologies available today are inadequate for the scale of the problem. They merely slow down the fall of our planet into a climate abyss. And soon, we will cross the point of no return. So that begs the question, do we as humanity even possess technologies needed to clean up the oceans of micro and nanoplastics at all? Or are we doomed?
The technology is already here. When moisture evaporates, microplastics rise from the surface of the water into the atmosphere. To clean the ocean and atmosphere of micro and nanoplastics, we need a planetary scale filter. This role could be fulfilled by atmospheric water generators, AWGs, if deployed on a large scale. These devices convert atmospheric moisture into clean water.
And water evaporates every day from all our oceans, seas, and lakes. When it goes to a certain height above a certain point, it goes below dew point and becomes a cloud. And then, of course, the wind blows that cloud. When it comes below the dew point, it becomes rain and changes state again.
Extracting moisture from the air stimulates evaporation. With each cycle of evaporation, a new portion of micro and nanoplastics rises from the surface.
The way the machine is designed, the air that comes into the machine is filtered to start with. Then the moisture is condensed out of the moisture that's in the air. So the only thing that the machine is seeking is the H2O molecule, which is smaller than a piece of microplastic.
This way, we will clean the ocean of microplastics and reduce the strain on the planet's water resources. In doing so, we will provide drinking water to the regions that desperately need it. However, this must be done on an industrial scale and implemented at a global governmental level.
In this way, atmospheric water generators function as artificial filters integrated into the planet's water cycle. Additionally, the ocean cools during the intensive evaporation process. The technology for condensing water from the air works on a principle similar to plasmapheresis, a medical procedure that cleanses blood. Just as plasmapheresis removes harmful components from blood and restores the body's immunity, AWGs filter out nanoplastics from water vapor, restoring the ocean's natural functions. This approach cleanses both the atmosphere and the ocean of microplastics. Furthermore, AWGs can supply the necessary volume of purified water for all domestic and industrial needs. Used water should be returned to the soil, where it interacts with microorganisms that break down nanoplastics, enriches with minerals, and undergoes natural purification. As moisture replenishes, dried up groundwaters and rivers will begin to recover. Soil will become fertile, and vegetation will thrive. Moist soil will also help moderate temperature fluctuations, while water's high thermal conductivity will efficiently transfer heat away from hot areas. This is especially critical given the planet's changing climate.
Using atmospheric water generator in each home, then you will not ever use these plastic bottles. So by using the atmospheric water generator, we are seeing that we will solve the water issue. We will reduce the footprint that is from the plastic industry. We will reduce the carbon footprint from the transportation, and we will help the environment to return to the natural cycle.
Could this technology provide water to people in deserts?
The technology there can create water anywhere, because the technology is used in such a way heating and cooling creates condensation. So whether it's in Devil's Valley in Nevada or in the Sahara Desert, we can still make water there. So we can make water anywhere on the planet.
But this raises the question, could we dry out the air in the process?
That's one impact we have. When it comes to the water content in ambient air or in the atmosphere, as I mentioned previously, there's absolutely no way of extracting or disturbing the natural balance of the atmosphere, because it's simply too big and it's too powerful. And even if we would create an awesome, enormous machine, constantly sucking water out of the atmosphere, it would immediately, with its other hand, snatching water back from, the Pacific or the nearest water.
Moreover, when we remove excess moisture from the atmosphere, the frequency of extreme precipitation and winds decreases. Simultaneously, the atmosphere is cleansed of methane and CO2 in just 2 to 3 years of active use. Atmospheric water generators could significantly purify the ocean and atmosphere. Cleaning the ocean of microplastics will restore its thermal conductivity. The ocean will once again begin to transfer heat to the atmosphere, which will then dissipate into space. This will mitigate the destructive impact of natural disasters. Moreover, transitioning to AWGs will reduce dependence on terrestrial and underground water sources. AWGs can produce the required water volume for drinking and industrial needs. They will be vital during a water crisis and ensure stable water supplies. This will allow for the full achievement of several UN Sustainable Development Goals at once. For a global-scale ocean cleanup, all water must come from the atmosphere, meaning a complete shift to AWGs. The more atmospheric moisture we extract, the more evaporation intensifies, accelerating the ocean's cleansing process. To power AWGs efficiently, we must use fuel-free generators, FFGs. Obviously, we must also stop dumping waste into the ocean. In addition, we need to overhaul the sewage systems. These steps will lead to a scientific and technological revolution, ensuring sustainable water supplies and reducing the negative impacts on the climate. As a result, within 3 to 5 years, the ocean's thermal conductivity functions could be nearly restored, and we must do it all in the shortest possible time.
So this is a great news. Technologies capable of saving our planet and humanity from destruction, they exist already. So we have a chance. All we need to do is organize and implement the solution. But here's another issue. The climate models that account for all anthropogenic factors, as it turns out, do not reflect a reality. That is, what was forecasted to occur 100 or 150 years from now is unfolding right before our eyes. So scientists are starting to recognize that there's something else at play, something beyond just the human influence. This something else is causing more and more discrepancy between the model and the reality. And let's call that the factor X.
The X factor. Global average temperatures don't fully reflect the reality of climate change, as some regions are warming significantly faster than others.
The change that occurred in 2023 was so large and much larger than anything that we've seen before. And so it demands an explanation. The models that we have used to simulate the climate are not offering a very good explanation for this. And what we find is that there are some changes in the patterns of the ocean currents and the atmospheric winds as a consequence of all of this. And so although there's extra heat, it's actually getting moved around by the ocean currents and by the atmosphere and concentrated in certain regions in ways that we've never seen before.
The global scientific community is increasingly alarmed as worsening climate trends are outpacing predictive models. Why are modern climate models so far off the mark? Some experts suggest the answer lies in the mysterious X factor. The record-shattering temperatures of 2023 have nonetheless alarmed scientists and hint at some mysterious new processes that may be underway, says NASA's top climatologist Gavin Schmidt. It wasn't just a record. It was a record that broke the previous record by a record margin. He adds, the long-term trends we understand, and it's being driven by greenhouse gases. It's being driven by anthropogenic effects. But what happened in 2023 was that. And then plus something. And that plus something is much larger than we expect or as yet can explain. In this film, we've explored one of the factors contributing to ocean warming, and that is changes in the very properties of ocean water. Nanoplastics are affecting water's heat capacity and conductivity, trapping heat in ocean waters. Additionally, greenhouse gases warm the atmosphere, which in turn heats the ocean surface. But are these factors enough to drive such dramatic ocean warming, given that solar radiation remains unchanged and anthropogenic factors are accounted for in climate models? It raises the hypothesis that additional heat is entering the ocean from another source. Research shows that the middle depths of the ocean have warmed 15 times faster in the last 60 years than during the previous 10,000 years. And this warming is accelerating. To heat such deep layers where sunlight cannot penetrate, an enormous amount of energy is required. For instance, right off the coast of West Antarctica, the deep waters of the Weddell Sea are warming in a peculiar way. While the top 700 meters of water remain nearly unchanged, temperatures in deeper layers are steadily rising. There are several theories to explain this anomaly, but none have been conclusively proven. Where is this additional heat in the ocean depths coming from? It's commonly believed that heat from the Earth's interior is negligible. But could we be underestimating this factor? Our knowledge of the ocean's depths is limited. Over 70% of the seabed lies at depths greater than 3,000 meters, 9,800 feet. Research at such extreme depths faces significant technical challenges. Submersibles and sensors rarely reach these areas, and calculations often rely on outdated data. We simply have no clear understanding of what's happening on the ocean floor. For instance, scientists only recently discovered 19,000 previously unknown undersea volcanoes.
We've only mapped something like 5% of the ocean floor. Until we map 100% of it, we're gonna still be working in the dark.
Oceanographer and professor at University of Maryland, Arthur Vittorito, observed that since 1995, the number of earthquakes occurring along mid-ocean ridges has been increasing.
Now, what I have done is I have plotted the mid-ocean seismic activity and plotted it against the global temperature. And in this case, we're looking at a 2-year lag. In other words, the seismic activity precedes the global temperature change by a factor of 2 years. The more seismic activity you have, the more magma is moving through the system, is percolating through the system. And these magma melts get up over 1,000 degrees. So this is what we're really looking at here. We don't have direct measurements of how much magma is coming up. All we can do is measure the amount of seismic activity because we have a global seismic network for this.
Thus, Arthur Vittorito's research shows that ocean warming is also significantly influenced by endogenous processes, such as seismic and magmatic activity.
My research suggests that geothermal forcing is a significant factor in global warming. And we can see here that the ARGO data shows global temperature variations for various depths over the past 20 years. Most of the heat is being transported at the surface, but we also have an amplification from underneath. So it's coming from both directions. There is no way, as we point out here, if we magnify this part of the plume in here, there's no way that the warmer temperatures sitting below the surface can be coming from the surface, because you have a cool anomaly here and a warm anomaly here, but it's not able to break through this layer here known as the thermocline. The thermocline is actually a strong dividing line in the ocean that divides warm surface temperatures known as the mixed layers with much colder water beneath it known as the deep layer. It's actually, the system is coupled. It does break through the thermocline, and there's some interesting studies that have just come out recently that talk about how this thermocline has actually weakened. It's synchronous with the increase in mid-ocean seismic activity. All right, so it's not just occurring randomly. So you have cooler water at the surface with warmer water underneath. Okay. This is evidence of geothermal heat rising from lower depths towards the surface. upward convection of heat has further amplified the process, weakening the thermocline and raising the global ocean heat content.
We're faced with a new reality, the factor X. This is likely the primary driver behind the worsening state of our planet, and this has become more and more evident over the last few decades. And micro and nanoplastics are amplifying its effect. Yet, one critical question remains. What exactly is a factor X, the force that is heating water from the depth of the ocean?
ALLATRA scientists have been studying the X factor for nearly 30 years. This independent international group of researchers includes experts from diverse scientific fields, such as nuclear physics, astrophysics, geology, mathematics, biology, and medicine. They have come together to conduct interdisciplinary research encompassing climate and geodynamic changes. Based on extensive years-long data analysis, ALLATRA scientists view the X factor as additional heat generated by magma ascent due to cyclical planetary processes. Fundamental scientific findings and actionable climate recommendations can be found in the report on the progression of climatic disasters on Earth and their catastrophic consequences. This report was personally presented to Pope Francis at the Vatican by Marina Ovtsinova, president of ALLATRA. After careful examination of the data, the Vatican awarded the ALLATRA movement an apostolic blessing from His Holiness for its efforts in climate and environmental work. The report was also presented at COP16 in Colombia and COP29 in Azerbaijan, receiving high praise from climatology and ecology experts. Currently, the report is available for review on the official United Nations Conference website and the ALLATRA website. Solving the challenges of planetary and human safety amidst global climate change requires the united efforts of the entire scientific community. No single country or organization can tackle this problem alone.
So as we can see, the situation is quite alarming. Beyond the well-known causes of climate change, there are additional factors that remain poorly understood and require further study. But the challenge is that these efforts will need to be carried out while our climate conditions will continue to worsen at an accelerating pace. In other words, humanity will have less and less time to respond to the escalating climate change. But the worldwide implementation of atmospheric water generators, this is a crucial step towards addressing this crisis, because these devices will enable us to clean micro and nanoplastics from our oceans, to restore our planet's water cycle and heat balance, and ultimately to stabilize the climate. The atmospheric water generators can give us a precious time to sustain humanity's scientific and industrial potential. And with time, there comes hope and opportunity. At the same time, we must create conditions within society that will enable scientists from all countries to collaborate openly, share knowledge freely, and work together for the benefit of humanity and its survival. But achieving this requires a global peace, a lasting peace between all countries. Only then can we truly confront and overcome our climate crisis. We would like to emphasize that the ideas and research directions presented in this documentary offer promising and practical approaches to addressing the climate challenges that we're facing today. Detailed investigation of these concepts, they will lead to breakthroughs in understanding the processes that are unfolding in our planet. The power to create change lies in our hands. Together, we can transform challenges into opportunities for extraordinary progress. The time to act is now, for our planet, for ourselves, and for the generations that will follow.